Hello all and welcome to my YouTube channel. So today in this particular video, I'm going to be discussing about how we can train a custom object action model using Detectron 2. So in my previous video, I have demonstrated an tutorial regarding an object action using Detectron 2, which was just an kind of an introduction to the Detectron 2 and how we did the inferencing and how we downloaded the model. It's all remains the same. So if you haven't watched that particular video, please do go and watch it. So this is the particular video which I'm talking about, which I uploaded in last week. So you can just go over it and just understand like the basics of Retron 2 framework and how it is being used, and I've explained everything in depth. So before you continue with this particular video, just go and watch that video so you can understand how the inferencing and how the Retron 2 is working at the back end. So once that is done, then you can jump over here to get to understand how we can train a custom model over our own data set, and let us progress with that. So with that consideration, I have one data set uh, which is on base of understanding or locating a package in a particular image. So you can see this is an image, it has this package, so we are going to identify this particular package by using Detectron 2. So if you slide over next images, you can see that these are the boxes we need to identify that. So these are two boxes. Likewise, we have images. So I haven't taken much images, it's all very like 19 images, and we are going to annotate it. So I will give just a brief introduction like how we going to do the annotation for this particular annotation model. So first, let us start with the LabelImg. I will open my LabelImg for annotation tool. For annotating, you should use LabelImg tool for annotation of annotation models. So for once I open this, I will just go to the open directory, and I will set a path where my data is located. So our prediction is train data is located in my train folder. So I'll select that folder. My particular image has been loaded, and I will change the save directory. So I want my annotation folders to be saved in a particular folder. So here I will create one new folder. I will say new annotations, and then I will select this folder to save my all annotation what I'm doing over here. So once that is done, the directory is setting up done, then we have to set this particular type of annotation we need to perform. So once you set this Pascal VOC, it will save the annotation in form of XML files. So for this particular object action model, I am going to using this Pascal VOC format. And once you select that, you can also select YOLO if you're training with the YOLO model. But right now I'm using Pascal VOC, so I will select with that, and I will create a bounding box by selecting that create bounding box, and I will select this particular box, and I will write category like package. So this is a class I am giving, and I am annotating it. And once that is done, I will save it, and once I save it, I click on this save button. I saved it, and once that save is done, I can just go to that particular folder where I have mentioned that the annotation should be saved. So you can see it has created an XML file with the same name whatever the image name has, and this is the annotation it has done. So you can see it has consist of the names and the bounding box information x min, y min, x max, y max. So this is how it is done. This is how you gonna annotate the images. And if you want to go with the next image, you can just click on the next button to get the next image, and you can start annotating with that. So I'm not going to do the whole annotation of these images. This is just an overview of how you can do it, but this is how we generally do it. And I have already done the annotation for it. So I have this train folder. This is the images, and for this all images I have this annotation folder I have created already. So these are annotations for it with all these classes mentioned here. So I have only one class present over here, which is package. So I just need to understand or extract only package from this particular image. So these are the two files. So in this particular Detectron 2, we want to extract the package object from the particular image, but we have the annotation in form of XML file. We want that it should be converted to the Coco format, that is a JSON format. So our annotations are in XML. We want these annotations to be converted into a JSON format. So for that particular thing, because JSON is actually accepted by JSON format is actually accepted by Detectron 2. So that's how we need to prepare it. So since we have saved our model in form of Pascal VOC, which actually saves the images in XML file. So we want that XML file to be converted to JSON file because JSON is accepted by Detectron 2. So for that, I have a script which is called voc to coco.py file. So what I'm going to do is I'm just going to convert this all XML file into a JSON file. So this all images information, this all image information, this all image annotation informations present in XML file will convert it to a single JSON file. So it won't be like this particular single file is converted to single JSON file, and then this, and for this file a different JSON file will get. It's not going to be that. It will be a single JSON file which consists the information of all this particular XML file. So this is how we're going to do it, and this is the format generally Detectron to accept. So for this, I have this voc to coco.py file. So I'm just going to run this script to convert these annotations to JSON file. So let me just run this particular script. So I'm going to type python voc to uh, I will specify the annotation folder where I have XML files, and then I have to specify the output location where I am to save it. So I will save it in results folder with output.json. So this is the particular destination I'm giving for saving my JSON file. So once you run it, you're gonna see it has created an output.json file. So this is the JSON file I have created. So if you go into this, I think I don't have app, but yeah, the all information of these files, all over the information which were there in this XML file had gone stored in this .json file, and this is all set. We are set to train a particular Detectron 2 model. So we have this train images, and all of the information of these images are being stored in JSON format. So we just need this train images folder and this JSON file. That's it. So once we have this file, we'll just compress into a particular zip folder. So once I compress this particular into zip folder, I will get this train folder. So this train folder consists of only this image folder and this output.json file. So once that is done, I will just upload this particular train zipped train folder to Colab, because I am using Colab for training a particular Neutron 2 model. So I have imported over here. You can see this is a train.zip. I have imported it over here, and uh, I will install the installations of the particular Neutron 2 once I unzip this particular train.zip file. So because I have already done that unzip.train.zip file, because it takes time to unzip it. So this is the files which are present inside it. So you can see inside the train.zip it has this, and so all these informations are being stored over here. So let me once run this as well. uh just to all just to all So it's got executed, and now you have everything present over here. So you can see it has executed everything. So I have this output.json file as well, and train images over here. So once this unzipping of train.zip is done, then we need to install all the dependencies of Detectron 2. So I've explained everything, what are the Detectron 2 is, and what are the dependencies are there. So I've explained in my previous video, so do go and watch it. I'm just going to install it over here. So just run this particular command, and you're going to install this particular dependencies, and I will check for your torch regions. So guys, I have already explained all these steps, so I don't want to repeat it unnecessarily, because it would take time to explain all these things again. So if you are new to this particular channel, so please go and watch my previous video for this particular understanding of why we are doing this. And once that is done, then you can come back to this particular tutorial and understand it properly. So we'll install this particular dependencies. I've explained all these cells over there, and I have already unzipped it. And now this is a new thing which we are not going to see over there in my previous video. This is a new thing because we are training a custom model. So these are the imports we need to understand now. Okay, so we are taking this data set from Detectron 2, and we are using this register Coco instances. So this is the function, this is a class. We are going to use it from this particular data set, and in this particular function we are going to specify the experiment name. So we will specify like any experiment name. I will say experiment, and then we need to specify the that output.json format file where it is present. So I have this. So remember, this consists of the information of XML files, annotation of XML files. So we have to provide the path of it, and we have to provide the images path of it. So this is how we register the instances in format of Coco, and we'll just run this particular cell, and then we have to use this metadata catalog and dataset catalog. So this data catalog is being imported from here, from this data. So why this is being used? Because we want to collect the information whatever we have in this particular output.json file, and data catalog will handle about the training file, that images. So it this particular category handles about the images. So this is what it does. So this particular line will help you to capture information of all the annotations, and this particular line will help you to understand or capture the information of images. And I have to specify the experiment because we have specified all these things in experiment. So let me just copy it and paste it over here. So that's done, I think. Yeah, so this is how we generally do it, and this is the mapping. You can see we'll apply a mapping for you. So this is what it is doing. So it has created an ID of annotations, and it is mapped with a particular uh, output folder with the images. So this is what this step does. And let's visualize few of the annotations what we have done. So this particular cell will help you to visualize the annotations. These are the our annotations what we have done. So it is just taking the files from this particular data dictionaries that we have taken it. So it is just taking that particular image and mapping it to the mapping annotation over it. So you can see these are annotations we have done, and these are not the predictions. These are just an overview of whatever the files we have with annotations. So once that is done, you have to import this particular data onto a repo, and then our training configuration cell is here. So let me go one by one. So for training, you have to import default trainer. In my previous video I've explained we have one more default predictor that is used for the prediction, but for here we are using default trainer from Detectron to engine, and we are using this get configuration, which actually help us to get the configuration for files for the required kind of model we want to train. So let's suppose we want to train for our faster RCNN or RCNN or marked RCNN. So that kind of models we need configuration files. So for downloading those files for those particular models, we need this function get config, and we're going to use this particular function over here. So once that is done, we're going to initiate this get config function, and we'll install this config, and then we're going to specify the model configurations. So from where we're going to get this particular model configuration is from this particular return to model zoo. So if you go into this particular repository of return 2, you're going to get model zoo over here, and you have to just click over here, and you're going to get to go scroll it down, and you can get to go, you can see uh, the models you can use for. So right now I'm using this particular model, R50 FPN. So how you gonna get this particular destination? You have to just specify the path which is present over here at the top. So you have to copy it and paste it over here. Similarly, you have to specify the weights. So you have to specify the weights, you have to copy it over here, same path. You can see the same path, and you have to specify the experiment over here, because the datasets are stored in experiment, and this is a number of worker. You need to specify. You can increase it to 3 4, whatever the efficiency of uh, the hardware you have. I've specified it to, which is default, and you can just give an image per batches. I have given 2, you can specify 4, or you can specify 6 based on your hardware configuration. So for this particular Colab tutorial, I am just taking a batch images per batch is 2. You can specify the learning rate, and you can specify the iterations, that is epoch. I've given 100 just for the tutorial to be shorter. I don't want to waste time in training. And you can see that you can specify the image size as well. So if you're given any images of different size, so it will just adjust it to the same size, which is 128 by 128. You can give it to 640 by 640 as well. But if the configurations are not, the hardware configurations are not high, you can get set it to 128. And here you have to specify the number of classes. So I have only one class of present over here, which is package. And this is how I'm going to do. And once the training is done, I'm going to save this particular uh, trained model over output directory, and specify this configuration file and put it inside this default trainer, which will train the training of this particular model by using all these configurations. And I have initiated a resume, and you can just you can just prepare this particular config file according to your need, and you can just have to run this particular cell by specifying trainer.train. And once initiate this run, you can just see the training will start as soon. So you can start seeing that it has started loading particular model. And I think it has already been trained for 100 epochs, because before preparing this particular video I have checked few iterations. Let me go with 200 epochs. So it will resume the training from where I left in my earlier training. So because I have specified the true, so it will start training it from 101 epoch. So let me run this. So it will start training it again. And you can see starting the training from iteration 100, because I will before getting into this particular video I will train the model for 100 epochs. So since I'm not trained from scratch, now I am trained from 100 epoch, but the step remains the same. You can specify 100 or 200 or 300 according to your need. And since I specified that resume is equal true, so it is starting from the same point from where I left. So you can see it has started training. Training has started, so it will train for few more epochs, like 100 iterations more. And then once that is done, then we can get back to this particular visualization, like what are the efficiency and how that thing has been done, like how the loss is being getting decreased, and we can visualize it by using TensorBoard. So let's wait for the training to be done, and then we'll get back to this particular iteration. Okay, so finally our training has been completed for more 100 epochs. So you can see iteration 119 has been completed. So you can see the loss has been decreased from 0.05 to 0.036, and this is time taken. And you can see the memory consumption of GPU is 4.2 GB. Time taken for this particular epoch. And you can see the loss has been reducing from previous iterations. So we will visualize this particular thing, and once that is in, so we'll just visualize it using a TensorBoard. So it will take time to initialize, so let's wait for a few seconds to get it appeared in the window. And once that is done, we can see proper uh, losses and proper learning rate. So you can see all the information has been printed over here in particular TensorBoard. So you can see the loss class. You can see the loss has been decreasing from all previous epochs. So these are the epochs, and the learning rate has been increasing then decreasing. So this has been set up by this particular faster Arsenal. And you can see the total loss has been decreasing all the time. So if we train it for more longer time, obviously the accuracy going to increase more, and you can get to converge to a particular local minima or minimum point where you want to be. And uh, this is uh, this is where this cell where I am going to be saving my particular experiment, what I have done in model final model underscore final dot pth. So this is a final trained model I am going to saving. So this is the model which I have trained over here. I'm going to save it over in this particular path. and I just want to test it out on, like, I just want to test it out on few samples of images. So this is the threshold I'm giving. So this is zero point 0.5. You can play around with this, and I'm just going to pass the test image by specifying this configuration dataset or test. So I'm just using the similar test whatever I've trained for. So it's in the uh, experiment cell, and then I'm going to use default predictor class, and inside that I'm going to pass these configurations, and I will run this particular cell so that it will generate the predictions. And let's just visualize this particular predictions by using this particular instance, but particular this cell. So let's run this, and you're gonna see that the predictions of this particular trained model for 200 epochs. So you are seeing that this is the prediction image. So this is a new image we have given, and this is the image we are getting, and it is taking few seconds to iterate for more images. So let's wait for it to visualize it. And you can see this is the next image. You're seeing that this is the new image and it is predicting to over here. So this is our trained model, and once that is done, this all training is done. You can see the predictions. You can evaluate using TensorBoard. You can print out everything, and once that is done, you can just download all these configuration files, whatever the files you have, and you can just dump it over here in this particular directory and you can download it. So all the file which you have trained, all the model files will present in this output folder. You can just check it over here. You can see this model underscore file.pth. It's in the PyTorch format. You can download this model, and you have to download this particular config file, which are just doing it by running this particular cell. And once that, if you run this cell, you get the configuration files .yml. So if you want to deploy this particular objection model anywhere, so you have to have two things, which is this model underscore final.pth file and this configuration file. So you have to download these two files and proceed for the deployment of this particular objection model. So this is what the tutorial of custom objection of the model using Detectron 2 is. And if you have any doubts, or if you want to support this particular channel, you can subscribe, and please do watch my previous video on Detectron 2, and I've even prepared a video on YOLO version 5. You can watch those videos and understand the proper understanding of objection. So this is all about this particular video. I hope you enjoyed this. Keep supporting this channel. Thank you.